In this video I will go over the homework that follows the lecture 15.2 that focuses on solving the surface area problem. And as always, I hope that you watched the lecture, and let's go ahead and jump right into the homework. And in the first problem we are asked to find the surface area of the surface generated by revolving this graph around the x-axis. And we are going to use these universal formula for the surface area. And you can find this formula in the lecture in the very last few minutes of it. This is the formula. Let me just show it to you for a second. And these are 4 different ways to interpret it, depending on what function is given, how it is given, what is the interval, and how is it rotated. So this is the formula, and I'm going to write it here as 2 pi r ds. And in our particular case, we are given a function and it is rotated around, we really need to pay attention to that, it's rotated around the x-axis, and the function is given to us as y equals f of x. So it seems like we're going to be using the interpretation provided in the upper left part of the table. So let me write it over here. So we're going to be integrating from a to b of 2 pi f of x 1 plus f prime of x squared dx. And we're going to set it up in 3 steps. We are going to first find the derivative. It's going to be 3x squared over 6, which is x squared over 2. Then we're going to find the integrand. So we're going to, well, the hardest part of the integral is the square root part, so let's just go ahead and compute that. Or not compute, but rather find it in the simplest form. So we're going to have a square root of 1 plus x squared over 2, and we have another square here. So it's going to be a square root of 1 plus x to the 4 over 4. And now we can set up the integral for the surface area. It's going to be the integral from 0 to 1 of 2 pi. F of x is x cubed over 6. And the radical is this. All with respect to x. Now that we have set up the integral, it doesn't matter where it came from. We just have to find this integral, and we're going to do this integral with substitution. And the substitution, the new variable will be t, and we're going to take inside of the radical and set it to be the new variable. So dt will be x cubed dx, meaning that instead of dx, we can write 1 over x cubed dt. And also, because it's a definite integral, we should consider switching the limits of integration. If the original limits are from 0 to 1, the limits for t can be computed using this formula. So when x equals 0, t is 1, and when x is equal to 1, t is equal to 5/4. So this is my substitution. And now we're going to continue with the integral. We have integral from, and here I guess we can take all the sum of the constants out. So we have 2 pi over 6 integral from 1 to 5/4 of what we have here, x cubed. Then we have the radical, but inside now we have t, and instead of dx we're going to write 1 over x cubed dt, and we see how this was a good substitution because things kind of cancel out nicely, and now we should be able to find this integral. So it's going to be t to the power 3/2 over 3/2, so it's 2/3 t to the power 3/2, but we also have pi over 3 in the front, and we evaluated it from 1 to 5/4, so 2 pi over 9 is out, and here we have 5/4 to the power 3/2 minus 1 to the power 3/2, which is just 1. And I have to enter the exact answer, so I'm just going to type it exactly the way I see it in my solution. So we have 2 pi over 9 times, in parentheses I'm going to type 5/4 to the power 3/2, all that minus 1, and let's see. And we got it right. Here we have some Desmos presentation, I guess, which could be nice. Let me see. Hold on, who's gonna be? I see, right there. So we need to really zoom in over here to see what's going on. Anyway, at some point we shouldn't be relying on the visual of the problem, and we should be able to solve the problem analytically. Problem number 2. We have the function given to us as g of y on the interval, and I guess let me go back here real quick and specify. So it is really important not just how the function is given, but also how it's rotated. So here the function was rotated around the x-axis. Okay, and let's make sure we note that every time. So here we have a function g of y. It is on the interval from -2 to -1, and it's rotated around the y-axis. Okay, so that means we're gonna use the universal formula, but we're going to use the bottom left interpretation of this formula because of how the function is given and how the solid of rotation is created. So it's going to be the integral from c to d of 2 pi g of y 1 plus g prime of y squared dy. And we're going to find this, we're going to set it up in 3 steps. First we're going to find the derivative of g, which is just -1. Then we're going to find the radicand by finding the radical here. So we have, did I say radicand? Integrand. 1 plus -1 squared. And here we're getting kind of some trivial results, because when you rotate a line segment, you get frustum, right? So we should be getting something very simple, because the surface area for frustum, we have a formula for it. So we shouldn't expect anything complicated. Now we're setting up this integral as the integral from -2 to -1 of 2 pi -y plus 5 times the square root of 2 dy. And once you have this integral, it doesn't matter where it came from, you should be able to find it. Here we're just going to do some basic maintenance. We're going to take out 2 pi square root of 2, and what's left we're going to integrate, and it's just a linear function. So we get 2 pi square root of 2 negative 1/2 y squared plus 5y from -2 to -1, 2 pi. We have to enter the exact answer, otherwise I would have thrown it into calculator already. So here we have to be careful. We're gonna have this expression, and it's important not to lose track of all the parentheses. And here we have negative 1/2 minus 5, and here we have -2 squared is 4, so we have negative 2, so it should be plus 2, and then we have negative 10, so it should be plus 10, so altogether we have 12 over here. And it should be pretty simple to finish this. -5 plus 12 is 7. 7 minus 1/2, it's 6.5. And 2 times 2, so we have 13 pi square root of 2 would be my final answer. Let's see if it's correct. 13 pi square root of 2. All right. Let's do problem number 3. We have a function. We are given the interval with respect to x, and we're rotating around the x-axis, meaning we're going to first use the universal formula, but we're going to interpret it like this. We're going to set up the integral in 3 steps. First we find the derivative, then we find the integrand, and the integrand is equal to, I'm just going to start simplifying it as I'm writing it, and I guess we can set up the integral now. So the surface area will be equal to, and let's do some basic maintenance. Let's take out the 2 pi. We have 2 pi integral from 2 to 4 of f of x, so it's going to be 3 radical x times this. But the radicals actually can be combined anyway. Now that it doesn't matter where this integral came from, we can entirely focus on finding this integral. So let's take out that 3 from inside. Let's combine the 2 radicals using the property of radicals, and this is what we end up with. Now we're going to do this with substitution. So let's set t to be equal to x plus 9/4. So then dt will be equal to dx. And the new limits of integration we can compute. So when x equals 2, t is equal to 17/4. And when x equals 4, t is equal to 25/4. Looks correct. So our new integral will be 6 pi integral from 17/4 to 25/4, and we have square root of t dt. So that integral is pretty easy. It's just a power rule. So we have t to the power 3/2 divided by 3/2, so it's 2/3 t to the power 3/2. But this will be evaluated at these values of t. So finally we have, let's take out the 2/3 out, so we have 4 pi, and now we're throwing the boundaries inside of the antiderivative. So this to the power 3/2 minus this to the power 3/2, and there are parentheses here. So it doesn't make sense to try and simplify it further. Let's just enter the answer. We have 4 pi, and I'm going to enter this giant parentheses. We have to the power 3/2 here and here, but here we have 25/4, and here we have 17/4. And looks like we got it. The fact that the mastery bar moved backwards is concerning, but the more practice, the better. So let's go to number 4. We once again given a function. We are given the values of y, so we have to be careful here. And we are rotating around the y-axis. So while the universal formula will tell us that the integral is this, we have to be careful to, when picking the correct interpretation for the given scenario, and again reviewing all 4 interpretations, what do we see here? We're rotating around the y-axis, and we can choose to integrate with respect to y or with respect to x, but we just have to carefully adjust the formula. So we can do it one way, and then, because we already did it this way, so let's go this way, right? So let's integrate it with respect to x, and that means we need to find the limits, a and b. So here's the formula, here's the interpretation I'm choosing. Again, remember this a and b are for x. And here I just need to do a quick conversion, right? So we have the limits for y, so these are my c and d, but for each y I need to compute x. So in this case I just need to solve this equation for x. So x will be equal to 1/4 of y plus 1. So when y is equal to 1, x is equal to 1/2, and when y is equal to 3, x is equal to 1. Now that we have pretty much settled on the interpretation of this formula, we're now going to set up this integral in 3 steps. First, we're going to find the derivative of f, it's just 4. Then we're going to find, and did I forget the 2 pi over here? Yes. Then we're going to find the integrand. It's going to be this. Now we're going to set up the integral. It's going to be the integral from 1/2 to 1 of x times square root of 17 dx. which is square root of 17, 1/2 x squared from 1/2 to 1. And again, keep forgetting this 2 pi over here, 2 pi over here, and let's not forget 2 pi over here, times 1/2, and we have this. Simplifying, so we have 1/2 squared is 1/4, 1 minus 1/4 is 3/4, so we have 3/4, so 3 pi square root of 17 over 4. Alternatively, we could have set up the same problem like this. We could have interpreted this universal formula as the integral of g of y and all of this, where g of y, we would have to actually find it. It would be 1/4 of y plus 1. And now with that, so again, also remember that the values for y were given from the beginning. Y was equal to, y was ranging between y and 3. And now if we're integrating around the, rotating this piece around the y-axis, then this is the way to go. So let's just set it up real quick. G prime of y would have been 1/4. Square root of 1 plus g prime of y squared would have been 1 plus 1/4 squared would have been square root of 17 over 4. And then the surface area would have been 2 pi integral from 1 to 3 of g of y, which is 1/4 y plus 1, times square root of 17 over 4 dy. And I bet that this integral is the same as 3 pi square root of 17 over 4. You can check that, and if it's not, let me know. But I believe in the power of this universal formula. I have no reason to doubt that, and unless this is going to be the wrong answer, but it's not. So yeah, let's move on. All right, this time we're asked to use the calculator, which is nice. Will save us a little bit of time. We have a function, we have an interval in terms of, I have to assume that it's in terms of x, and we're rotating it around the x-axis. So this universal formula can be interpreted as the integral from a to b of 2 pi f of x square root of 1 plus f prime of x squared dx. And to set up this formula, we'll do it in 3 steps. So first, let's find the derivative. It's going to be 2 over 2 square root of 4 minus x squared times the derivative of 4 minus x squared, which is negative 2x. So things cancel out here. The integrand, or this part of the integrand, will be set up like this. It doesn't look pretty. Luckily, we're not doing this by hand. I guess I don't have to simplify, but let's just take it a bit further. So after you square it, you're going to have 4 minus x squared in the denominator. But the numerator can be found by actually performing the addition. So we're going to have 4 minus x squared. And after you square it, it's going to be 4x. Looks like it's some nice formula, but we're not actually concerned with this. So we're just going to set up this surface area integral. It's going to be an integral from -1 to 1 of 2 pi. F of x is 2 times square root of 4 minus x squared times the square root of, it looks like we could have done it by hand. So I'm just simplifying this expression here. And it seems like things cancel out nicely here. So this cancels, this cancels. Why would they ask us to do this with technology when it's actually quite easy to set up? So we have 4 pi, and square root of that is just 2 minus x, absolute value of 2 minus x. But 2 minus x on this interval, it's always positive, so I can just write it like this. And we have to integrate this from -1 to 1 dx. Well, hopefully I'm not making a terrible mistake here. Here we have 2x minus 1/2 x squared from -1 to 1. And, well, if I am making a mistake, then I'll show you a nice way of how to use technology for problems like this. Then, as a bonus, here we have application of the fundamental theorem of calculus. And we're almost done. We have 2 minus 1/2 plus 2 plus 1/2 cancels, and the answer is 16 pi. Well, as a bonus, as promised, I'm going to show you how to use technology for problems like this. Let's go open Desmos. Let's introduce our function. Our function is 2 times the square root of 4 minus x squared. And we're actually going to set up the integral from -1 to 1 of 2 pi. And the beauty here is that you can just literally type this. Hopefully it works. Looks like it did, right? So, and we expect the answer to be, what was it, 16 pi? So for comparison, let's type here 16 pi. Oh no. Well, that's how we know the answer is wrong. The answer is not 16 pi. Let's double check the work real quick. But is it some number of pi? It's definitely some number of pi, so let's just throw like 1 of pi here to remove the pi. I guess some square root is present there. Maybe it was more complicated than I thought. So, let me double check. So we have... So let's start with the derivative. So we have 1/2 of that in the root times the derivative of it, which is -2x. So I'm pretty confident in this. Now we're simplifying it. So the only step that I didn't have to do was right here. And oh my god, this is 4x squared over here, not just 4x. So it's going to be 4 plus 3x squared here. Oh boy. Right, so definitely. Well, at least you got something out of it. Now you know how to use Desmos to make your life easier. So this is actually just 4 plus 3x squared. And we cannot easily integrate that, right? So here we have square root of 4 plus 3x squared. To integrate this, we would have to do like some inverse trig substitution, and we are not asked to do any of that. So let's erase all of this. I really thought there for a second that I'm smarter than this homework. I wasn't. So we already got the answer, right? It's going to be 55.98236.7, whatever. And we have to round it, I assume, to 4 decimal places. So the final answer will be 55.9824. But again, pay attention to how we set it up. Actually, we didn't actually have to find the derivative. We could have asked Desmos to do it all for us. And this was number 5. Let's move on. We have another problem where we just have to set it up. Oops. So let's let me write what's given. Interval from 5 to 7. We're rotating around the x-axis. And we're going to use the universal formula. And we're going to use this interpretation. Once again, why are we using this interpretation, not the other one? Because of how everything is given to us. We're given literally everything in terms of x, so why wouldn't I use this interpretation? So to set up the integral, we're gonna find the derivative. It's gonna be 1 over 2 square root of 4x minus 6 times 4. Then we're gonna set up this integrand. And let's simplify it just a bit. We can totally simplify it just a bit more. So we have 4x minus 2 over 4x minus 6. I know it may not be helpful in terms of actually advancing our integral, but we are not asked to find the integral, we're just asked to set it up. So the integral is going to be from 5 to 7 of 2 pi f of x times the radical and this is where you can see like this actually cancels out, right? So let's go ahead and type the answer. We're going to have an integral from 5 to 7 of 2 pi square root of 4x minus 2. Let's go ahead and check. Looks like we got it. That really advanced us on that progress bar pretty far, so maybe a couple more problems and we'll be done. Here we have the function given to us as a function x of y, and we given the boundaries for y, and we are revolving around the y-axis, so we're gonna use this universal formula but we're gonna interpret it as this, which is pretty natural given the way the information provided to us. We're going to set up this integral in 3 steps. First, we're going to find the derivative. Then we're going to find this part of the integrand. And then we're going to set up the integral. SA stands for the surface area. And the integral will be from -3 to -1 of 2 pi y plus 3 squared square root of 1 plus 4 y plus 3 squared. And we're going to use Desmos. And one way is to manually type this integral. So we have integral from -3 to -1 of 2 pi y plus 3 squared square root of 1 plus 4 y plus 3 squared dy. That's one way. Alternatively, what we can do is we can define a function g of y in terms of y, and what we can do is we can set up this integral without kind of manually computing all these ingredients, and we should get the same exact answer, which we're not getting because I don't have the answer to that question. I thought it would be the same. I think I forgot the well, g of y doesn't have a 2 over here to start with. And now we have the same exact answer. So I'm pretty confident that, now that we found it in like 2 different ways, I'm pretty confident that whatever answer we will input will be the right one. So rounded to 4 decimals, so we get 53.2259, which rounds to 60. And we got it. So number 7 is done. Let's go ahead and try number 8. Number 8 is very similar to the previous one, except it's very similar in the sense that we don't have to really think hard in terms of which interpretation to pick, because everything is given to us in terms of y. So while we are considering this formula, we're going to consider this interpretation of this formula. And if you need more details on this variety of interpretations, I will refer you back to the lecture. We're gonna do it in 3 steps. First we find g prime negative 3/4 y squared. Then we compute this part of the integrand. It's going to be 1 plus, let me just square it right away. And now the integral for the surface area will be the integral from -3 to -2, 2 pi g of y times the radical dy. And this is what I'm going to be typing here as my answer. So the upper limit is -2, the lower limit is -3, the integrand is 2 pi, let me take the negative out, so 2 pi, I guess we can just remove this 2, just divide by 2 over here, and we have y cubed, and we have a square root of 1 plus 9y to the power 4 divided by 16. And it's good. That was surprising. Took us a while to get to the bottom 50%, and we flew through the second 50%. If you have any questions about finding the surface area still, please feel free to reach out.